Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Raul Klingberg, your host. Today I'm going to have a rather lengthy discussion about the root causes for the difficulties that I had in forming the D-tubes for my wing and what went wrong with the molds, why it went wrong, and how I fixed it. So if you have a great desire for intimate details of technical problems, this is just the video for you. And if you want to see flying videos, please go to other videos on my YouTube page and watch those. So for those of you with a technical inclination, let's get on with the discussion. Okay, welcome back. And to reiterate, I'm going to discuss the root causes for all the problems that I had in molding the D-tubes. And you're looking at this and seeing, oh, Raul got the Mylar smooth on the mold. How did he do that? I thought he had a problem with it buckling up, and I did. And there might still be a few little issues. Now, I can't stand here and say, I have completely solved this problem and we're going to have no problems going forward. But I do understand now the root causes. Once I explained it to my buddy Bob, we talked about it on the phone, I didn't quite understand all of the problem at that point during the discussion. But within 24 hours, all of a sudden my brain kicked in and said, aha, I know what happened. And I thought I'd transfer that information to you guys so that if you ever want to go make male molds for molding composite components, you'll know what not to do. So with that said, let me get on with discussing why this method worked for the shorter panels, the tip panels in the center section, and not for these really long panels, and how I went about fixing it. So I've pre-made a little drawing for you here, and hopefully I can get this up to where you can see it. And I have to look in the viewfinder in reverse and make sure that you can actually see what I drew here. So what I have here at the top of the drawing is what one of the blanks looked like for the wingtip D-tube. And this was about 7 feet long. The part itself is about 6 feet long. So I had an extra 6 inches at either end. And these were cut out of the blue Dow extruded polystyrene styrofoam. And I have videos up on the site where you can go see us cutting that. Now, whenever you hot wire foam, there are some unique things that occur. One of them is wire drag. No matter what temperature you choose, no matter how slow you go, the center part of the wire will drag behind the tips. It trails the tips, and it's just due to drag in the foam and the wire trying to cut its way through. And you can go infinitesimally slow, and you'll still have that wire drag. And it's always a compromise between the speed at which you cut so that you don't get too big of a kerf. If you go super slow, you get a really wide, uneven kerf from the wire. Or if you go too fast, you get too much drag in the middle. Now, drag on a flat surface is a non-issue. If you're doing just a single plane, you have flat templates, it doesn't matter if the center of the wire is dragging behind the tips. It's all going to be flat. If you're doing a curve, however, it makes a big difference. And how you go about cutting that curve can make a big difference. And we did the foam cores for making the tip panels in the center section differently than we did the foam cores for the main panels, and it caused problems. So here's what happens. When you're cutting one of these blanks here to make a male mold, you have a template at either end, and you hot wire around the template. If you've never done it before, you just have a series of numbers on there, and you make a cut where the person at the big end is going a little bit faster than the person at the small end, and they count out those numbers and try to stay in time with each other to keep all of the cut lines along a particular percentage of chord of the wing. And if you have a couple of characters that know what they're doing, it comes up pretty good. Now on model airplanes, we don't have the leading edge of the foam. We leave it squared off. You actually start your cut further along on the template. And later on, we glue on a piece of balsa wood or something else, and we sand that to shape. Well, I really didn't have that option for a full-size glider because I don't have 7-foot-long big blocks of balsa wood that are nice for sanding, and I can't imagine what it'd be like to sand one either. Now, you might be able to CNC mill something and stick it on there, But remember, I'm trying to create a methodology here that the average home builder can use. So none of those seem to be within their bailiwick. So I had to find out a way to cut the curve shape of the leading edge directly in the foam without using a big CNC hot wire cutter. And that's what I've been attempting to do here. Now, by definition, when you hot wire, the hot wire, because it's touching the template here, the part cut here will be the exact same size as the template. And also out here at the tip. It will match the template. However, in between, because of wire drag and sag and various other factors like the wire's a different temperature at the end than it is in the middle because of heat transfer of the foam, it's not a straight line. So you have to compensate for that somehow. Now, what I did on the tip sections, of course, is I made a mold that was extra long, right? And I realized that this was going to happen, and I did a variety of things to work around it. And the part was actually made inside, well inside of where the templates were. And as you get away from the template, this line becomes more straight, sort of. You're over a long distance, there's a very shallow dip. It's ostensibly a straight line. So I'm making a part that's inside of where the majority of the problem occurs. Now, of course, I've greatly exaggerated here. We're talking about a droop that might be a 32nd of an inch, a 16th of an inch, a 64th of an inch. Very small, but it's enough to potentially cause a problem. So if I eliminate the ends, I've eliminated most of the problem. Then the other thing I did with the tip ones, because this is a 7-foot long block and I have an 8-foot long sanding bar, I just sanded it to shape to get rid of these high points. And that required that I actually sand through the template. Do I have one of those templates here? Oh yeah, I do. Here's one of the templates. It's made out of this press board stuff, and this is glued on the end. And I just kept sanding, and I would sand right through the templates and try to keep the shape the same, just here at the leading edge, to eliminate this problem and make this one nice straight line. Now, I never could get it perfect. You can't get anything perfect in your home shop, but close enough. And then by the time I lopped off the ends, or actually the part's built to here, slightly past the part line, but not to the end of the template. So when I was done, I'm molding on a surface that was essentially planar, a planar curve, because of compensations that I made up front to deal with this wire drag and wire droop. Excuse me one moment. A little extra caffeine to keep me going. And there was another thing that we did on the tip panels. On the tip panels, on the template, here's how we made our cuts. We set up a little popsicle stick right here, tongue depressor like this, double face tape it to the template, and we came in that way. And we would come in on a number 1 cut here and come into this tangent right here. And this point here where we entered the foam was very close to the template. So we had a short distance to go, so there's very little wire drag initially, and then we're on to what is, for the most part, a fairly flat part of the template. Same thing was done on the upper surface. Picked up a tangent here that we stayed away from the steepest part of the curve and came in that way. So this left a big peak of styrofoam on the part, around the mold, when we were done cutting. And then I had to come in and sand that all off. I came in with a knife and cut off the majority portion of it, and then I spent a day sanding and shaping to the templates. Now, that was on the blue Dow styrofoam, which the XPS sands really nice and smooth. So it was fairly easy to do, an afternoon's worth of work. So the tip ran just fine. Made both tips, made the center section the same way. The D-tubes for the center section, the molds were made the same way, and the Mylar wrapped around them, just peachy. I really didn't have any problems with it. And of course, as I mentioned in my other video, many people asked, how are you going to do 18.5 feet long? And I said, I'll figure it out when I get there. And it's involved a little bit more figuring than I planned on. Now, when we got to doing the panels, or the blanks, excuse me, not the blanks, when it came to cutting the mold for the 18.5 foot long, well, we had to do it in 3 sections. We had 3 foam sections, because you can't go out and get a block of styrofoam, as far as I know, that's 20 some odd feet long. And I can't imagine what it'd be like to build and handle a 20-foot long hot wire. I don't think anybody's ever done that. Maybe they have, and they could tell me their secrets. But I decided to do this in 3 sections because I could readily get styrofoam that's 8 foot long. Do 3 sections. Each section's 7 foot or less. Good to go. Okay, and in the process of doing this, so we got a foam blank like this, rectangular foam blank, and we got the template glued on it. And I thought, you know, I got a guy helping me that really knows how to hot wire. I know how to hot wire. We are going to do this the fancy way, and I'm going to cut down on the sanding because I know that the white bead styrofoam doesn't sand for diddly squat compared to the blue extruded polystyrene. The blue stuff sands really nice. The white bead, the beads roll up at first. It's kind of rubbery. It moves on you. Really hard to get it sanded accurately. So we're going to be fancy, and we're going to put our popsicle sticks on like this and double face tape them on the template. And we actually ended up tack gluing them in place so they'd stay. And we're going to come in from the side here like this, and we're going to pause here for a 1, 2, 3, 4, 5 count so that the middle of the hot wire can catch up to where we are. So the ends of the hot wire are here, and the middle of the hot wire is back here somewhere. And we're waiting for it to catch up. And then when we think it's caught up, now we can't see the wire. It's just a judgment call. So you say, okay, it's there, and besides, I'm melting the bejesus out of the foam here on the end, and let's get going. So it's pause, 4, 5, go. And we go around the curve this way, and we did the same thing going the other way. So we cut off this triangular portion of the foam so that we're pretty close here, and we had some grooves and high spots and stuff, but it was really easy to fill and shape and saved me a lot of sanding time. Unfortunately, what happened was, so when we came in here, especially coming this way, from the number 2 position, coming from the bottom to the top, and we pause here, pause, and then go. It is very clear now that there's no way that we could pause long enough for the center of the wire to catch up over the 6.5 feet. You know, it's got 3 feet to the center of the wire. So we would start going around this curve here at the tips, at the templates, and the wire is still back here somewhere. So the wire wants to go straight. The wire only knows how to go straight. The wire doesn't know how to go around curves. So we're here at the tips, right? At the templates, we're down here, but the wire itself is back here in the middle of the length. Somewhere in here, the wire's back here still, and the wire wants to go straight. So the wire wants to actually go across like this. It doesn't want to go around that curve. It just wants to go straight to where the ends are. So what we ended up doing was creating a cup. It's probably some hyperbolic something or other, math function, between the ends and the center. So it's not just a matter of the leading edge being bowed down, but the whole thing is smaller and cupped in along its entire length because of the drag of the wire. So it's not only dished this way, but it's on every line, it's dished in. So when I went and sanded the final part, and I'm working with my sanding bar across this area here, and I'm filling and sanding and so forth, I'm not realizing I'm not really getting all of it. Now, you're saying, Raw, why didn't you put your straight edge there and check it? Well, I thought I did. Put my straight edge up on there and go, hey, it looks pretty good. I didn't realize I'm looking for a 64th of an inch, a 32nd of an inch, a tiny amount. To me, it looks good. Eyeball, looks good. It's not like I was putting feeler gauges in there and checking it, because I didn't realize that the Mylar was going to be so darn picky and that this had to be so exact. Now, when I had done this, because I sanded right through the templates and made it all smooth all the way around, it was fine. It was one planar curve because it was done with a long sanding bar very carefully all the way around. That didn't happen here. There's a cupped section, and it's on both sides here in this area. Now, that cup is really small. Probably at the most on these molds, a 32nd of an inch. It's enough to cause a problem with the Mylar, but aerodynamics, doesn't know the difference. This is not a laminar flow airfoil. And that little dip there over 3 feet, it's not a big deal. It's not really going to impact the flyability of the aircraft. Nor is it going to impact the nose ribs that go in here, because the nose ribs are going to get custom fit. I have blanks cut out. They're a little bit oversized, and I'll hand fit them. So it really doesn't matter what this exact shape is right at the nose. In fact, nose ribs don't even have to come all the way to the nose. They can end up short. That's done many times in aircraft. They run them across or do some other shape in here because it's very hard to fit the rib to this exact curve that you want. And sometimes this leading edge area here on the D-tube is just reinforced and the ribs stop short of that. That's done too. So you might be wondering, Raul, why did you not do the same darn process and sand right through the templates until you had this thing straight along its whole length? And why didn't you lop off the ends, right? So you're working on the straight portion because it worked before. Why didn't you do it again? And there's a somewhat fascinating explanation for that, and I'm going to show you right now. I hope you can see it here. There's a line here on the surface. Let me see if I can tilt it a little bit and bring it around so you can see it. This line that I drew on the foam is where one of the joints is. This is one section of foam, this is another section of foam. This is where the templates would have been, right there. So I would have had a larger one of these templates here when we made the center section, and I had a matching template here for making the tip section. And the reason I did that is because I knew I had to join up these three sections of foam, and they had to be dead straight, and they had to match here at the joint. And I thought the only way that I'm going to get these darn things to match is to match the template faces, because the wire will have been on the template, and this tip section is going to match exactly to this section because those two templates were done as a pair, and they match exactly. And if I were to sand through the template until I had the whole leading edge straight, well, not going to match to this template over here. There's no way I'm going to end up sanding this template the same amount, the same shape as I sand this one. And if I make it extra long and lop it off, I know I'm going to have that little bit of bow, but where am I going to cut it? And not only that, how am I going to cut this face? The face could be tilted this way when I cut it. It could be tilted this way. I could have all kinds of alignment problems. When the blanks were made, I had T-squares and straight edges, and those faces were lined up with each other in the blanks. And the only way to keep them lined up was to work off the template face. So I never went inside of the template like I did for the tip molds, and I didn't sand through the template until I had the whole leading edge straight and smooth, because I wanted this interface here to match exactly. And I couldn't quite figure out how to provide extra for sanding, cut it off, and have them match. I probably could have done that with some finagling, get it lined up with a bench. Okay, so I got a gap and I shove a bunch of epoxy filler in there with microballoons and then sand it over. I probably could have done something like that, but I didn't. In for a penny, in for a pound. Here I have $500 worth of molds sitting in front of me, maybe $600, and parts, and don't want to throw the mold away and don't want to make new molds at this point. So what do? I got molds that have some weird hyperbolic cosine, who knows what. Some math nerd out there will write in and tell me exactly what that shape would be. And I know there's a mathematical equation for it, I just don't know what it is. Math was not my strong suit. Engineer was no good at math. I like to think I'm like Einstein in that way. Anyway, so what do? Well, it dawned on me that I could fake the situation that I had on the tips. And that instead of doing a Mylar wrap from here to here, what if I did a Mylar wrap from here to the middle? That might constitute straight for that section. And then I do one over here. And then I overlap them here in the middle, match cut the Mylar, match cut at where the templates were, and maybe it'll work. Maybe this will be straight enough. So that's what I tried. And I can't show you the whole D-tube here, but it really is all here. There are, this section of Mylar runs from essentially where the joint is. Now I made the overlap here vertical because it's easier to deal with. And it runs just about to the middle of that foam mold that was cut. and then I have another section that goes from the middle to where the next template is. I got 2 going out this way and 2 more at the root. So there's a total of 6 sections of this Mylar on here. And each one of these is going to have a seaming strip behind it. When I put the fiberglass onto the Mylar and mold it to the foam, there will have to be a 4-inch wide strip here. So I've marked the foam where those strips are going to go. That's also a registration mark for where we're going to put the Mylar. I also made registration marks up here, and I got some down here, so we know where all of the Mylar aligns when we go to put it back on. And there'll be 6 sections of fiberglass on the outside that butt together on the surface, but underneath have a 4-inch wide overlap. It's analogous to having short pieces of aluminum sheeting to build a metal aircraft. And they're usually joined up at a rib, and you overlap the metal and you rivet both edges, and it's one piece of metal when you're done. So we're going to do the same thing in composites here. There'll be a seaming strip here 4 inches wide that they glue to, and there'll be 5 of those for the 6 sections. And I think it'll be fine. Now, I'll probably put reinforcement on the inside also, because we are concerned about local buckling in all of this design, and an area like this where you seam would be susceptible to local buckling. So not only will I have a splicer on the outer surface, I'll go in on the carbon fiber on the inside, and I'll put a doubler in there also, and it'll add a little bit of weight. But it has solved the problem. I was able to put the Mylar onto the male mold. I got it flat everywhere. Having a little problem with one section, but I got a little bit of a low spot on the leading edge that I can fill in and reshape it, and the Mylar will sit flat. But this sits nice and flat. The vacuum bag will pull this in really tight to the foam, and it might actually add in the layout, because we can work it in sections. I'll put the joining strips on here first, the 5 of them. They'll start to tack up a little bit, and then come in with these and do them one at a time, working from one end to the other end, overlapping them, and bing, 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 out along the length of the spar, the D-tube. Now, I will have 5 flashing joints that I have to carefully scrape down, do a little sanding and polish so that I don't go through the fiberglass. And there will probably be some marks on the surface, you'll be able to see them visually, but aerodynamically, it's not going to be a big impact. Now, a couple of the interesting things that I ran into along the way that I'd like to transfer to you, so you can avoid them or use them in the future as you see fit, is some people might be thinking, well, why don't you just take a bunch of microballoon filler, the lightweight stuff, put it on the whole leading edge here like this, just slop it on there. So what if it takes you a whole quart of the stuff? Just slop it on there, wrap the Mylar around it, stretch it tight, and that way you're creating a leading edge shape that matches what the Mylar will find acceptable. And that's the first thing I thought that I would do. I thought, oh, easy, blah, blah, blah. And you might be able to see it right here through the Mylar where I've taken it back off. So I get it on here. I thought, well, it's never going to dry underneath the Mylar. So I punch a bunch of holes in the Mylar so it can dry and air can get at it. And I thought, good. So I wrapped it, put them on there, rubbed my hand on it so it's all nice and smooth, and went to bed. And got up the next day, and here, let me show you what happened. This is fun. This will give you a chance to have a little laugh at what goes wrong. Here's one of my mistakes. And they always look like a mess like this. Look at that. That microballoon filler stuck to the Mylar better than it stuck to the foam. It was still a little bit wet, didn't cure all the way. It cured where I made the holes, made a nice smooth surface there where the Mylar was, but it really didn't stick to the foam. So I go lift up my molding material, and it just took it right off the foam. It was like, wow, that was one of the biggest holy blankety blank blank moments that I've had recently. It's like, wow, what a waste. Anyway, so this is often what my mistakes look like. I don't know, could you call it a mistake? Bad idea. Not really a mistake. Not like I did something wrong, never done it before. I didn't know what right and wrong is. But here, if you ever think you're going to do something like this, think twice. Don't work so good. So, and now I'll tell you about one that was a little more successful. Now, if you watch the other video, you know that I said something about I'm going to come in here where they overlap, where the sheets of plastic overlap, and I'm going to score a line here. Now, normally when you match cut sheets like this, you just cut right through both of them. You go into the middle overlap, you put a straight edge on here and go whoop, right through both sheets. And by definition, they match. and they'll always have a perfect match. Well, I can't do that here because I cut the foam core for the part underneath. I can't cut all the way through. And I thought I would just score. I'd run my blade along the edge of one sheet and score the next sheet, and that'll match. Well, I discovered with the Mylar, it's so slippery, even the knife blade wanders around. You're trying to stay up against one edge, and it goes whoop off this way, or it skips over and goes that way. Oh, it's a disaster. So I thought, oh, I need to mark the Mylar and cut it after I lay it flat. I put a straight edge on it, cut it, and follow that mark. So I tried various pens and scoring tools and all that other stuff, and nothing really worked. And then I thought, oh, tape. I'll just butt tape up. The tape, surprisingly, masking tape's about the same thickness as the Mylar. And I thought, I'll just butt it to wherever the edge is. And then when I take it off, the tape's right there, and I can put a straight edge on the tape and whoop, cut it, and I'm good. And for the most part, that worked out really well. But when you're of a certain age, that some of us are, seeing the edge of one clear sheet against another clear sheet is challenging in this at a very high level. And trying to get that tape butted up against the other sheet before it sticks to this one, oh, that's even harder. So I have a strip on here, and you can see how I did it. It's buttered right up against there. But this took 3, 4, 5. And if I would show you if I could, but it's way down at the other end. What I discovered to do was this sheet that's on top. This sheet is on top of this sheet. Before this sheet gets put on, because this is a factory edge, it is dead nut straight via the factory. I laid masking tape along the edge with about half of the masking tape hanging over the edge of this sheet of Mylar. And then before it's applied on here, I folded it back around underneath. So this factory edge of the Mylar has masking tape applied to it on both sides, and by definition that edge is straight. So when I laid it on here, now I got something that's standing up about 14 thousandths of an inch. And because it's standing up a little extra proud, it was real easy to come in with this tape along the length and just stick it here. And I have my magnifiers on. Where are they? Do I have them here? Where'd they go? Oh, yeah. There we go. You got to have a pair of these. You know, if you're of a certain age, you got to have a pair of these going. Slap these on so you can see what you're doing. Get that magnification going. And with the magnifiers and my fingers and the tape raising that Mylar up, it just made it super easy. So if you ever have to match cut Mylar or something clear like this on an overlap, use one of the factory edges to wrap tape around it, and then it's real easy to butt tape the tape. And when this comes off, then I'll just cut along this, and I'll take the tape off the other sheet, and they should match up fairly nice. Now, the final nice thing that occurred out of all of this, if I can find it, oh, it didn't go in there. So I'll just explain it. I had 40-inch wide Mylar that is 50 feet long, and a roll of that costs about $50, about $1 a foot when you buy it in quantity. And roll it out along the 18.5 feet here, cut it off lengthwise, and when you wrap it, well, you got a whole bunch of extra here because this is tapered and it's big enough to fit one end, but way too big for the other end. So you end up with a lot of wastage that way. But you know, when you're building an aircraft, material wastage, people just kind of go, you're building an aircraft, they're expensive. You're going to throw materials away. However, by doing it in 6 sections like this, I was able to turn the roll. This section that you're seeing here, like this section here, that's the width of the roll of Mylar. Aha! So now I can put the Mylar on this way, and I have the added advantage of the stresses that are in the Mylar that were put in by rolling it up at the factory. Oh, I can work with those. That curved direction I put right around the D-tube so that it's already pre-curved in the proper direction, the direction that I want. And I'm using sections of the Mylar, so the usage of the Mylar was much more efficient. The wastage goes to practically zero, very little wastage. So a little bit more work to finish out the surface at the end, and but I saved on Mylar, and there's a little bit more setup work here, but it might actually be easier to lay up. Now, can I stand here and tell you I'm 100% sure this is going to work? No, I would never do that. Been at this too long. I say this has a 95% chance of working. And what if this doesn't work? Well, then it's back to the other method of I'll do a wet layup right onto the foam. I'll do a peel ply surface on the outside. I'll come back with that body filler stuff that I was talking about, the glazing compound. I'll glaze the surface, sand it, smooth, wet sand it, make it really smooth, and then put the covering on it. And nobody will know the difference. It'll just be considerably heavier that way. So this is my last ditch effort to make the D-tube a little bit lighter and saving all of that work of applying glazing compound to, well, let's see, we're talking 260 divided by 3, let's go, about 180 square feet of surface to be glazed and sanded, and that's a massive job. So if I can avoid that, that'd be great, and just take care of the seams. So there we go. That's the root cause of the problem. In the future, how would I do it differently? Well, I think we come down to the conclusion that the home builder would not use single-use foam molds like this, not for something long. If you're doing panels that are within the length of a block of foam, 8 feet, works great. There's lots of different ways you can work with it to get really fabulous parts out of it. But when you want to do something really long like this, to put 3 sections together and have them come out straight, there's just too many ways to go wrong. You can't do it in the average home builder shop and have it come out well. Major struggles here just to get a couple of decent parts. So we're rethinking how the molds are done. I mentioned that in the other video, a series of templates, maybe with aluminum sheeting inside of them, go with a female mold. You can buy aluminum sheet in very long rolls. It'll behave like the Mylar, spray mold release on it. Maybe we do something like that, and the templates are laser cut or water jet cut. But have to do something different. I don't recommend the male foam molds for anything really long unless you know some secrets that I don't know on how to make this work. But it is quite challenging. I could have gone back and we probably should have cut the leading edges the same way that I did for the tips, where we came in at that angle like this rather than coming in this way and trying to be fancy, and just struggled with sanding it down. That might have helped the problem. But we still would have had dishing on this curved area here probably, or I would have had a sand all the way over. And then I had the issue with matching up the templates at the joint. I don't know how that would have come out. So that's water under the bridge. That's work behind me. Not going to go back and redo it. I'm going to forge ahead here with the molds that I have and do what I need to do to pull a couple of good parts, move ahead with the aircraft, and get something that we can test. So I hope we all learned something along the way, and you don't have to make the same mistakes I made. Or maybe you can take what I have done and add to it and do some new tricks and figure out another way to make molds really cheap for high-end composite parts. Different ways of doing this at home. And if I've achieved that goal and we've all learned something, we're good. Everything's worked out well. And in the meantime, I want to keep working. Please keep following on YouTube, and if you have a mind to, and you like the work that I'm doing, you like everything that you're learning, maybe you'd like to go over to my Patreon site. There's a link down in the description. Go on over to Patreon, and you can sign up monthly, and there's different levels that you can sign up at and help support this project. And I got lots of goodies over there for you. Go over to Patreon and sign up. And sign up at Patreon, you get a free hat just like this one. They are super nice, embroidered. And you become a patron, you get one of these. If you become a patron, you also get a copy of the X-Plane simulator for my wing. And you get a free copy of a set of plans for the quarter scale RC glider. So there's lots of goodies there for you, and for a few dollars a month, and you can help support the project. It's greatly appreciated. And if you don't want to go monthly, you can go to PayPal, link down below. Send me $20 for a hat, or send me $15 for the X-Plane simulator. I tell you what, you combine them together, I'll give you a deal. $30 for both of them. You get a hat and the simulator, I'll do it for $30. You send $30 to rawkling@gmail.com on PayPal, and I'll get those off to you right away. So thanks for watching. Thanks for supporting. Please tell your friends, get them to subscribe. And I think in somewhere within 6 months, this baby's going to be done. We're going to be out at the sand dunes seeing how she flies. So hang in there with me, and I hope we learn more along the way. I'll be back to share it with you. Bye for now.